60 years ago, on October 4, 1957. The Soviet Union became the first country to successfully launch the artificial satellite Sputnik 1 into orbit, opening a new era of space conquest. Since then, thousands of artificial satellites have been launched. Dozens of spacecraft have returned to Earth to explore new territories. However, all those satellites and spacecraft follow physical laws, using engines to move and navigate. This has limited their operational range. Recently, NASA announced they have successfully developed a fuel-free propulsion system. This discovery seems to contradict known physical laws, opening opportunities for humanity to conquer space in the future. So, how did this story unfold? Let's explore together. In 2001, a British engineer named Roger Shire developed a project that could change the future of space travel. The project was named EmDrive. This is a concept for a spacecraft engine using microwaves to generate thrust. When Roger introduced the concept, all scientists found it violated the law of conservation of momentum and other physical laws. Therefore, many believed the machine only existed in science fiction movies. However, Roger still created a prototype of his own. He called his cone-shaped design EmDrive and claimed it generated thrust in the direction of the cone's base. Soon after, that same year, he established a company specializing in EmDrive research. By late 2002, he described a prototype that he claimed produced 0.02 newtons of thrust, powered by an 850W magnetron. The device can only operate for a few tens of seconds before the high-frequency tube failed due to overheating. However, to date, detailed information about the machine has never been published. Since Roger Shire proposed the EmDrive theory, many scientific organizations have shown interest, and they established testing centers to research this seemingly impossible machine, including NASA's Glenn Research Center located near Cleveland Hopkins International Airport. After many years of research and development, NASA scientists successfully built a small electric propulsion system, believed to operate based on the EmDrive theory, and they named the system NASA H-71M. Unlike traditional propulsion systems that require large amounts of propellant to generate limited thrust, NASA H-71M is different. It's designed to operate efficiently, using low energy to generate significant thrust. This is the prototype of the NASA H-71M engine. And here is the image of the engine mounted on NASA's 8-foot test stand. It was conducted by Dr. Jonathan Marquette. NASA stated that if small spacecraft use NASA H-71M engine technology, they could independently travel from low Earth orbit to the Moon, even to Mars. Currently, no satellite or spacecraft can independently fly from low Earth orbit to the Moon or other planets. To achieve this, they require assistance from launch rockets to generate sufficient thrust to reach those destinations. However, if spacecraft or small satellites use the H-71M engine, they won't need launch rockets and can independently fly from low Earth orbit to the Moon, Mars, and even more distant places. This vision truly resembles spaceships in science fiction movies, capable of flying anywhere without launch rockets. In essence, NASA H-71M uses electric fields to accelerate ions to generate thrust, also known as the Hall effect, operating on electrical power. This method is highly efficient, providing more thrust per unit of propellant than traditional rocket thrusters. NASA added that the H-71M engine can operate for 15,000 hours and process over 30% of the small spacecraft's initial propellant mass, allowing them to extend the reach of secondary spacecraft, deviate from primary mission orbits, and explore more scientific targets. This means NASA's H-71M engine has great potential for application in small satellites and secondary spacecraft in the future. Currently, NASA has licensed the H-71M engine to Space Logistics, a subsidiary of the giant Northrop Grumman Corporation. They plan to use the H-71M engine in MEP satellite missions. Each satellite will be equipped with 2 small thrusters based on the H-71M engine design. These MEP satellites will be attached to larger satellites operating in geosynchronous Earth orbit, (GEO). They will serve as propulsion systems to extend the lifespan of larger satellites. It's expected that by 2025, MEP satellites will be deployed to maintain the lifespan of 3 communication satellites operating in GEO. Scientists expect that with the addition of MEP propulsion packages, it will help extend the lifespan of larger satellites by at least 6 years. Using rockets and fuel as traditional propulsion methods is both expensive and inefficient, limiting mission duration and operational range. In contrast, ion propulsion systems like the H-71M will achieve higher efficiency by using electric fields to accelerate. They don't need to carry abundant fuel, significantly reducing spacecraft weight. NASA stated that the H-71M is just a small engine, aimed at expanding the range and extending the lifespan of spacecraft or satellites in orbit. They will continue to refine the technology to enhance engine performance and size, thereby enabling installation on larger spacecraft. If this becomes reality, sending spacecraft to distant planets will no longer be a distant dream for humanity. Currently, scientists are not only focusing on researching ion propulsion technology but also exploring other future propulsion engines, such as plasma propulsion engines, which operate on the opposite principle of ion propulsion engines, or electromagnetic wave propulsion engines that rely on the effects of magnetic fields, electron waves, or solar wind to push sails equipped on spacecraft. Moreover, scientists are even researching more advanced engines like V-site sails, photon rockets, quantum vacuum engines, or black hole starships, etc. NASA's successful creation of the H-71M engine not only opens new opportunities for humanity to conquer space but also proves that nothing is impossible. Engines that once seemed to exist only in theory have now become reality. Who knows, perhaps in the near future, scientists could create even more advanced engines to help humans build starships, similar to those in science fiction movies, to travel to V-sites. At this point, this video will take a break. Wishing you relaxing and informative moments. And now, goodbye and see you in the next videos. With warm regards, farewell.